Good morning, everyone, and welcome to this class. We were discussing work energy theorem in the last class, and we were discussing a problem regarding this work energy theorem. As you can see, the problem is there on the board. We had two blocks of mass m1 and m2. System was at rest, no friction. We release the system. The system goes down. When the block m1 moves down by height h, we have to find the velocities of both the blocks. Obviously, velocity of both the blocks are going to be same. If I call the velocity of block number 1 as v, which is downwards in green, the velocity of block 2 would also be v, magnitude wise same, but along right they are connected by the same string. The velocities in magnitude would be same. We had also seen by virtual work principle, which I am now highlighting in blue. By virtual work principle, the work done by tension, complete work but done by tension on block m1 and block m2, if I combine it, the work done by tension would be 0. Why it is going to be 0? Because on one block, if it is positive, same work would be negative on the other block. So we don't have to worry about the tension. Tension work done is 0. Apart from tension, what are the forces acting here? The forces acting here are m1g, which is the gravity force on block m1, m2g, which is the gravity force on block m2, and normal reaction n on block m2. We have also seen that the work done by this normal reaction, because the block is going to move like this and normal reaction is like this, work done by this normal reaction would be 0. Similarly, work done by tension, work done by this weight is going to be 0. Why it is going to be 0? Because weight is downwards and displacement is horizontal. The angle is 90. So far, so good. Do we understand this? Can I have some raised hands? Boys, girls, so far, so good. Now, we have solved this question using Newton's laws of motion. We find out the acceleration. Then we put the equation v square is equal to u square plus 2as. But now, what we are going to do is to solve this equation using work energy theorem. And we'll have to apply work energy theorem for both blocks together. Now, we can also solve this question by applying work energy theorem for one block, for block m1. If you apply work energy theorem, you can get the answer. For block m2 also, if you apply it separately, you will get the answer. But then, if I apply it separately for m1 and m2, I will have to find the value of t. Is there any problem? If the mic is not working, keep it aside. Concentrate on the class. Throw the mic away. This is the mic, and you throw it away like this, so it goes to hell, and we still stay in the class. Okay, throw it away. Throw it away. Concentrate on the class, not on the mic. If there is something that you want to ask sir. He'll type it. Listen to the class. Mic is not important. Let the mic go to hell. So we can solve this question by work energy theorem applied on block m1 or applied on block m2. But if I do it by m1 and m2, tension ka work done will not be 0, because separately on m1 and m2, tension is doing work. But if I combine m1 and m2, the work done by tension would be 0. Do we understand this? Therefore, the only way you can solve this problem with work energy theorem is by applying work energy theorem to the entire system. Entire system means entire system of block m1 and block m2. Now, if I apply it for the entire system, and that is what I wanted to tell you in the first case, that was the reason this question was given. How do I apply work energy theorem for an entire system? Previously, we have done it for one block. For one block, if I write work energy theorem, it will be work done by all forces will be equal to change in kinetic energy. Now, how do I write the work energy theorem for both the blocks together? Nothing changes. Now, instead of forces on one block, I'll have to find out forces on all the blocks, and I'll have to find out the work done by those forces on all the blocks, not a single one. But if there are two, I have to find out all the forces on two blocks, find their work done. If there are three, then for three. If there are four, then for four. So basically, now the equation becomes, I can write it like this: work done by all forces on all blocks is equal to change in kinetic energy of all blocks. I repeat, here I am going to apply work energy theorem for both the blocks together. I will find the work done by forces on block 1. I will find the work done by forces on block 2. Add them. And that will be equal to change in kinetic energy of both the blocks together. What are the forces working here? I will again point out the forces. Force number 1, gravity. Force number 2, again gravity. Force number 3, normal reaction. Then we have tension, but tension on both the blocks are going to do opposite works, not opposite works. If one is doing positive work, other is doing negative work. So work done by tension will cancel. So I don't have to take this work done by tension. Now, you know the work done by normal reaction, force number 3 is 0. You know that the work done by weight, number 2, that is also 0. Only one force remains. Can you now solve the question and tell me how will the equation look? I'll give you a minute. On the left hand side, I have work done by all forces. On the right hand side, I have change in kinetic energy of all blocks. Can you now solve the question with whatever description and whatever information I have given you? I'll give you a minute. If you can write the equation now, you will get the answer straight away. 1 minute. If you have any problem, please ask. I know mic is not working. Doesn't matter. Things happen in life. We come across unforeseen circumstances. But if we don't have something, we'll have to work without it. So let us leave it. Anyone can. Acha, okay. We don't have mic, so no one can talk. So I'll give you a minute. Then I will ask if anyone could do this. Are you trying? I don't see boys trying. I just see boys looking at the screen and wondering what is happening in this universe. Please try. If you don't try, nothing will happen. Just by being in the class, none of you are going to get into any college just by being in the class. But yeah, but by being in the class and working and doing, I can assure you that you will get a very good college, IIT or NIT. But you have to work. And I've said that many times. Work done by all forces is equal to change in kinetic energy of all the bodies. You have the answer straight away. I had given you this question for homework, but I don't think you would have done it. Anyways, doesn't matter. I had to discuss it in any case. Work done by all the forces. The only force that is remaining is this gravity, M1G. Now, how much work this does? This block falls down by H. Okay, I have someone writing something. Okay, good. See, we'll have to, if we don't have something, we make some arrangements and we get, you can just show it on the camera, but I can see it probably. Yes. Just bring it down, bring it side. Correct, correct. That is correct. Well done. That is correct. Correct, beta. What is your name? Oh, forget the name. We'll talk about that. That is correct, beta. Well done. That is correct. Whatever, could not see the face. Anyways, whatever the name was, you have done it correctly. Work done by all forces. There's only one force working. That is weight, M1G. M1G is downwards. The block moves by H downwards. So what is the work done by this force, M1G? That will be simply equal to, wrong color. That would be simply equal to M1G multiplied by H, and it would be positive because M1G is downwards and the displacement is also downwards. So the work done is M1G plus M1G. That is the only work done because that is the only force which is doing any work. Do we understand this? Can I have some raised hands? That we understand this? That is the only force that is doing work. Well done. Okay, good. Now that must be equal to change in kinetic energy of both the bodies. Let us talk about body number one. Which is body number one? Body number one is our block M1, which is all pink, 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 pink. Pink is said to be the color of girls. So M1 is girlish, whatever. I also will wear pink. I like pink. I don't know why it is girlish color. M1. M1 is block number one. Let us talk about the work. Well, let us talk about the change in kinetic energy of block 1. What is the change in kinetic energy of block 1? Final kinetic energy of block 1, half m1 v square minus initial kinetic energy of 1, which is 0. So it becomes half m1 v square minus 0. Remember, both the blocks are moving with the same velocity. Both the blocks are moving with the same velocity. That is block number 1. That was in pink. Now comes second block, M2G, which is all green. What is the change in kinetic energy of this block? What is the final kinetic energy of this block? Half M2 into V square minus the initial kinetic energy was 0. See, the entire question now becomes a single step question. The entire question is just a single step. Whatever I have done, whatever I have drawn, that is just a part of the diagram. And you should be able to draw this diagram in your head. So this entire question now becomes a question which can be done in one statement, one line. Now, if I go back, and if I tell you how we have done it previously, obviously that is also correct. Nothing wrong with it. Nothing wrong with it. That is also the correct method. You can see that method required a lot of calculations. First, we had to find acceleration. We had to draw all the forces, this, that, hanky panky. Then I had to use v square is equal to u square plus 2s. See, same question, same question. But now, why we are able to do it smartly? Because now we have become a bit more mature, and now I can use a different method. It's not a different method, as I told you. This equation number 3 that I've used here, which I am marking by arrows, we have been using it since class 1. No, not since class 1, since chapter 1. But we now know that this is work energy theorem. But this equation that I've applied here is work energy theorem applied on block 1. I've only applied it on block 1. So I had to take work done by tension here. Then you will say, sir, where is work done by tension? I don't see it. This acceleration that you see, that has the work done by tension here. This acceleration that you see, this acceleration comes from this force, and this force has that tension coming into it. And that is why this question becomes difficult, because we have to find out tension in any case. Because I cannot apply work energy theorem on one block and not take the work done by tension, because tension does work in that block. But here what I've done is I've done it smartly. I've realized that work done by tension would be 0. Whatever work it does on block number 1, if it does positive work on block number 1, it will do negative work on block number 2. As soon as that tension goes away, tuck, the question becomes simple. Am I clear? Do we understand this? How I've done this? Anyone has any doubts? If you have any doubt, you can ask. Chalo. So that was all about work energy theorem. Work energy theorem. Work done by all forces. So if you have more than one force acting on block, work done by more than one forces on more than one block, total work done would be zero. Total work done would be change in kinetic energy, and work done by tension, if you take both the blocks together, will always come to be zero. Shall I? Okay, I'll give you a minute to think about it. Else we will move on to the next topic. Anyone has any doubts? Please raise them. Okay. One more minute. Everyone has written this? Okay. Let me just open this. Okay, we got this. Chalo. Now, we are done with work energy theorem. The name of the chapter is work, power, energy. Power is still remaining. We'll do power at the end of the chapter. We are still on energy. On energy, we have done kinetic energy. We're also supposed to do one more type of energy. And what is that energy known as? That energy is known as potential energy. Did we start potential energy before? Why I'm thinking that we have done it? Potential energy. Any idea about potential energy? Anyone? Okay, there is no mic. I forget it that there is no mic. I don't think we have done energy, right? We have not done potential energy, correct? Raise your hands. We have not done enough. Okay, because one class we are discussing paper now, so it just got mixed up everything. Potential energy. Now, what do you mean by potential energy? Anyone has any idea? Okay, even if you have idea, you will not be able to speak up. But what do you mean by potential energy? Now, physics is pretty damn simple. In physics, whatever we call something, we mean the same thing. If I call an apple, in physics, it only means an apple. It does not mean an orange. So, physics uses simple English terms or Hindi terms, and those Hindi terms are used to understand something, and the meaning is same. Now, what do you mean by the word potential? Every one of you has the potential. If you put in the correct hard work, you have the potential to clear JEE. Potential. That is the meaning of the term potential. Make a sentence. Potential. What is the meaning of the term potential? Potential is the ability to achieve something. You can do something. You have the potential, you can do it. So, if I use that word in energy, it becomes potential energy. So, potential energy is an energy which someone has, but probably it is not utilized. It is stored somewhere. You have the potential. When you get into an IIT or an NIT, you utilize that energy. You convert your potential into result. So potential is you have that thing in you. You have to convert it into result. Potential energy. So what is potential energy? In simple terms, potential energy is an energy which is stored. somewhere which has the ability to do work or to be converted into some other form of energy. When I see kinetic energy is energy in motion. The energy is utilized, it is doing work. Kinetic energy, when someone has kinetic energy, it is doing work at that moment in time, it is doing work. But if someone has potential energy, probably at that point in time it is not doing any work, but it can do some work. So it has the ability that it can do work, but right now it is just relaxing somewhere. Okay, example of potential energy: if you have a hill and you have a big block on the top of that hill, a stone, if you just make it fall down, it can do some work. While it's sitting on the top of the hill, it does not do any work, but it has the potential of doing work. That is potential energy. So in short, what we can write about potential energy? In short, what we can write is energy acquired by a body, energy acquired by a body, energy acquired by a body by virtue of its position, by virtue of its position. Now, position may sound like a very simple term. So instead of using this simple term, we can use a bit complicated terms. Again, they are English terms and they mean the same thing in English. What they mean here, so by virtue of its position, you can call it configuration or arrangement. Now, what do you mean by this configuration or arrangement? I think while we are doing this gravitation, we are going to do gravitational potential energy also here. I'll give you an idea, but the exact idea of this configuration or arrangement you will probably get in the chapter of gravitation. So energy acquired by a body by virtue of its position or configuration. Where a body is placed, in simple terms, this is a body. Where it is placed, where it is, according to its position, I can call it configuration. Whatever energy it acquires is known as potential energy. Now, how do I understand this potential energy? Why this potential energy comes is a big question. Now, before going on to why it comes, let us first talk about these certain types of potential energies that you might have read, and that will give you an idea of what potential energy is. I am sure we have learnt about gravitational potential energy. Yes or no? Can I have some raised hands? We have learnt about gravitational potential energy. In short, I can call it GPE, gravitational potential energy. We might have also heard about electrostatic potential energy, energy acquired by a charge when it is placed in an electric field. I can call it EPE, electrostatic potential energy. This electrostatic potential energy would be coming in in the next class, 12th standard. In fact, 12th standard is all about electrostatics, electric current, magnetic field of current, EMI. That consists of around 2/3 of your entire curriculum. Electrostatic potential energy. Then you can call it elastic potential energy or spring potential energy. Elastic or spring potential energy, which is acquired by energy in a spring or by something which can regain its shape. I will call it SPE. S standing for spring potential energy. I hope you have heard about this elastic potential energy in the chapter on elasticity. Elasticity is already done. Yes, you might have heard this term, elastic potential energy. You have a rubber band, you stretch it, it will try to come back to its original position. That is known as elasticity, because when it is stretched, it acquires an energy that is known as elastic potential energy. We will not be dealing with rubber bands, but yeah, we will be dealing with springs. So I will call it SPE, spring potential energy. Now, as soon as you look at these three terms, gravitation, number one, number two, electrostatic, and number three, this elastic or spring. As soon as these three terms come, these three forces whether it is gravitational force or whether it is electrostatic force, they are a very special type of forces. In which category these two forces lie? Gravitation or electrostatic or elastic forces? What type of forces are these? We have learned there are two types of forces. All the forces in the universe can be subdivided into two categories. What are those two? The first one is known as conservative forces. The other one is known as non-conservative forces. Gravitation, electrostatic or elastic forces, they all fall under conservative forces. And we have done a lot about conservative forces. What are conservative forces? How do we find out conservative forces? How do we find out their work done? Their work done does not depend on path. In a closed path, the work done is always going to be zero, because in one path, if it's doing positive work, in the other part, it will be doing negative work. Conservative forces. Now, looking at these conservative forces and this concept of potential energy, it is very clear that this potential energy is associated only with conservative forces. That is the next thing that you must remember. Potential energy is the energy acquired by body by virtue of its position, where it is placed. It is also only associated with conservative force. If there is a conservative force anywhere, there would be potential energy in that space. So that is the second thing that you must remember. Number one, energy acquired by body by virtue of its position. Number two, it is always associated with conservative forces. It is always associated with conservative forces. Now, why is this concept of potential energy? Well, as you can see, this entire chapter, whatever we have done or whatever we are going to do, this entire chapter does not require the concept of potential energy. There is no question that we'll have to essentially use potential energy. Any question can be done without the concept of potential energy as well. We don't need it unless and until someone asks us a question specifically on potential energy. How much is the potential energy, or what is the change in potential energy? If someone doesn't ask anything about potential energy, this entire chapter does not need potential energy. This is just a concept that we have created. How and why have we created this concept of potential energy? It is only associated with conservative forces. You can see that. Now, let us again go back. Let us again go back and see why this concept of potential energy has come. Why this concept of potential energy come? It is associated with conservative forces. Now, in these conservative forces, whenever we are moving an object, the work done does not depend on path. Go from A to B, A to B. I go from path 1, which is upar wala path, or I go from A to B in part number 2, work done is same. Work done is same, or what it has got to do with potential energy? Okay. Now let us try to understand why we have brought this concept of potential energy. We all are experiencing a conservative force in our daily lives. What is that conservative force that we are experiencing? We are experiencing the gravitational force of Earth, and that is why it is easier to understand potential energy from the concept of gravitational potential energy. It might not be so easy to understand it in terms of electrostatic, because we have not seen electrostatic forces at work. So this is high time that we understand the concept of potential energy using gravitation. Now, whenever we are using this gravitational force, one question always comes into my mind: how does gravity work? That was a question even Newton was working on. That was the question even Einstein sir was working on, Sir Albert Einstein. And obviously, Sir Albert Einstein found out, and we right now know how gravity works. We are not going to get into that part because that is not a part of your curriculum. Because of masses, heavy masses, the space-time bends, and that is how gravity works. Anyways, that is not we are going to do. We are not going to discuss space-time here. In simple terms, if I talk, and again, I will only tell you what I want to tell you. That is the only information I am going to give you. How are we going to understand gravitational force works? We only concentrate on what we need to know. We don't need to concentrate on the entire universe. Entire universe is too big. We just keep our mind focused. What we need to understand. What we need to understand is here. This is body A. This is body B. Now, how does gravity work for us? For our understanding only. Body A has mass m1. Body B has mass m2. Now, we know that both these bodies will be attracting each other. So I'll join them by a straight line. Both these bodies are going to attract each other. Okay. This force F is the force applied by body B on body A. This force, equal in magnitude, opposite in direction, is the force applied by A on B. Magnitude is same, action reaction forces, directions are different. We all know this much about gravity. So this F is the force on M2 applied by M1. This F, same in magnitude, opposite in direction, action reaction pair. This F is the force applied on M1 due to M2. So far, so good. We know this. What is the difference of? Now, how I'm going to imagine this pink wala force? This pink wala force, pink force, is the force applied by M2 applied by M1 on M2. Now, how do I imagine? Let us say that I am block M1. I am block M1. Now, how do I attract the block M2? Right now, what he's doing to me is not important. What I am doing to him is important. How I'm going to attract M2? I have got mass. My mass is M1. How I'm going to attract M2? So how do I attract M2? In whatever space that is surrounding me, from me to infinity, I create something known as field. I create a field. What is this field? We call it gravitational field or electrostatic field. Right now, we are inside a gravitational field. Now, what is this field? This field is my area of influence, where I can influence people. Right now, you can hear me. My voice is audible. So you are my audience, and my voice is audible till the last person on the bench. Last person on the bench, can you see me? Can you hear me? Please raise your hands. Yes, yes, last person on the bench. Okay, so I am audible till the last person on the bench. That is my field of influence. I can influence anyone who's standing right at the last corner. So I have created a field where I can influence others. You can listen to me, you can hear me. So my voice is the thing that I want to convey, and my voice is reaching till the last person. The last person is my field of influence or sphere of influence. Similarly, gravity works. If I have to attract the last person sitting on the bench and I am block M1, what I'm going to create is I am going to create a field where if you come inside that field, you will start to experience force. So if you are the last person on the bench, if you come inside that, you will be able to hear my voice. So my voice is the thing that is attracting you. That becomes your field of influence. So wherever there is a conservative force, how does this conservative force work? These conservative forces are also known as field forces. We did not use this term before. We are going to use it now. These forces are also known as field forces because They work by the concept of field. And what is field? Field is an area in space where other bodies will experience force. So I am block M1. I am creating a field around me. Okay, now this is my field. Whosoever comes inside this field, he will experience my force. That field is known as gravitational field. Right now, we are all experiencing gravitational field. This pen is experiencing gravitational field. And that is why if I just leave it, what happens? It falls. Because this pen is under the influence of someone. Who is that someone? Whose influence this pen is in? It's not getting influenced by me. It is not getting attracted towards me. It is getting attracted toward the center of this huge planet, Mother Earth. It is under the field of Mother Earth, gravitational field of Earth, and it is getting attracted towards it. And we can see it. Earth, huge planet compared to us. Compared to other things, it is not even a dot. Huge planet for us creates gravitational field, and we all experience it. So force comes from field. So if I have to understand why M2 is experiencing force, I will understand, okay, block M1 is there. Block M1 is creating field. And when this block M2 comes inside that field, it starts to experience a force. So this F comes from field, which is gravitational field created by M1. Am I audible and visible to all of you? Can you understand what I am writing here? Block M1 creates gravitational field. Block M2 experiences gravitational force. So whatever M2 is experiencing is because of field created by M1. Let us come to block M1 now. Why is M1 experiencing force? The green force, the green Hulk. From where this green Hulk comes? Now the answer is just the reverse. Now forget about what M1 is doing to M2. Let us now become M2 and see. I'm M2 now. I'm also a mass. So I also have the liberty of creating field. I also have the liberty of attracting other masses. Because Newton doesn't say if one mass is attracting the other mass cannot attract the first mass. They attract each other because that is action-reaction force. So I am at liberty of creating my own fields. So M2 is also creating field all over the universe. M2 is creating field. When M1 comes inside that field, M1 experiences force. So this force comes because of wrong color. This force comes because of gravitational field created by M2. So far, so good. So we now understand the concept of field. What is field? I will just give you a small definition, which is much more than enough. Of in any case, you have to do it in gravitation. So what is field? Here, let us try to understand it in terms of gravitational field, because that is the only force that we are concerned about. Gravitational field. So how will I define this gravitational field? What is a gravitational field? Gravitational field. It's an area in space. An area in space where a body experiences gravitational force. So whenever something that has mass and it is experiencing gravitational force, well, voila, we have found out gravitational field. See this block, see this pen. If I just leave it, it falls. Oops, it really fell. If I leave it, it falls. We have discovered gravitational field. Yes, here there is gravitational field. And this gravitational field, as we all know, is created by Mother Earth. Gravitational field, an area in space where a body experiences gravitational force. What is the relation between field and force? We come to that, or maybe in the chapter on gravitation, we will be dealing in great detail. Right now, it's just a cursor for what is going to come. Gravitational field. That means we have two terms here. Number one, gravitational force. Now, why does this force come? The reason is number two, gravitational field. So we assume that there is a gravitational field, and because of this gravitational field, this gravitational force comes. But hella, are we deviating from the actual topic? Our actual topic was not gravitational field or gravitational force. It was potential energy. But this potential energy is associated with this field or force. So that is the third thing that you must understand. Gravitational, since we are easier to understand gravity, so it becomes easier for gravitational potential energy. That is the third term that we must understand. Gravitational potential energy. Number four, gravitational potential. Gravitational potential or gravitational potential difference. These are the four terms which are actually linked to each other. They are not independent. If you understand one term, you should be able to understand all the terms. Now, let us try to understand the main topic here. What is gravitational potential energy? Now, before understanding gravitational potential energy, let us revisit. The first thing that we have understood is wherever the mass is there, it will create field. If other mass comes in that field, it will experience gravitational force. So far, so good. So first, you need to have a field. Once there is a field, you will experience force. Now, very similarly, these two things are related to each other. Gravitational potential and gravitational potential difference is related to gravitational potential energy in the same way. It's a question like this: what came first, egg or the chicken? Field came first or force? Force came first or field? Potential energy comes first or potential comes first? Similarly question. Now, let us now revisit this entire thing in a different way. This pen is here. I leave it, it drops. Why does it drop? Because it is in gravitational field. It is experiencing gravitational force. It's here. Now I can understand it in this way that when it is falling, it is doing work, right? It is doing work. So when it is placed here, it has the capacity to do work. Because when it is falling from here, it is doing work. So when it is placed here, it has the capacity to do work. Am I clear? Do we understand this? When it falls, because of gravitational force, it can do work. That means when it is placed here, even though it is not doing any work, it has the ability to do work. It is not doing work, but it has ability. And why, how much ability it has depends on where it is placed. If it is here, further up, it has more ability. If it is further up, it has more ability. If it is very low, it has less ability. More, less. More, less. So it has this ability because it is placed somewhere. That ability is known as gravitational potential energy. This energy it has acquired is because of its position where it is placed. That is known as gravitational potential energy. Am I clear? That is gravitational potential energy. But now the question comes, then what is gravitational potential? Same scenario. This block is here. It can do work. It has gravitational potential energy. Now I remove this block, but the point is still there. The point is still there. This point is inside a gravitational field. If I place this block here, it has gravitational potential energy. It can do work. But when this block is not here, it is just a point inside a gravitational field. This point has potential. When I put a block here, it becomes potential energy. But if there is nothing here, just a point, it is potential. When the block comes, it becomes potential energy. It is same as there is a point in space. I am creating field. I am creating field. Earth is creating field here. But nothing is happening right now because Earth is creating field. But if I put a block, now Earth starts to attract it. So Earth creates a field. If I place a block, the block experiences force. Right now it is not experiencing force because there is no block. But if I put a block, the block experiences force because of field. Earth is creating gravitational field. This point has potential, but it can do nothing. It only has potential. But if I give it this block, now it has potential energy. Am I clear what I have done here? Field creates everything. Because of field, force comes. Because of field, potential is there. If I place a block, it becomes gravitational potential energy. Do you all understand this? Or shall I repeat it? I will try to illustrate it with a simple diagram. Maybe that makes things clear. So let us take that this is ground. This is ground. Earth is creating gravitational field. Let us say that, which is not exactly correct, but the gravitational field of Earth, which is denoted by G vector, gravitational field of Earth is vertically downwards. This G vector, it's a vector. Remember, gravitational field is a vector quantity. This G vector is the field or gravitational field created by Earth. This is the gravitational field created by Earth. It is vertically downwards. Nothing happens. Nothing happens here. There is only field which is created by Earth. Nothing else happens. But as soon as I put a block here of mass m, as soon as I put a block of mass m, this block of mass m experiences gravitational force. Field creates force. Field is always there. See, I can see infinite points in this space. This space has gravitational field. Not all the points have blocks or bodies there. I can see a lot of vacant space. But the gravitational field is always there. I put blocks at any of the points in this room, they will start to experience gravitational force. So all those points are points in the field. If I place a block or body there, it will start to experience gravitational force. Do we understand this concept of gravitational force being created by gravitational field? Now, instead of thinking in terms of force, think it in terms of energy. Think it in terms of energy. I'll draw the same diagram, but I'll draw it in terms of potential and potential energy. Ground. Earth is creating gravitational field. Everything comes from field. Okay. This is the gravitational field. This gravitational field now creates gravitational potential. So this point has, when it is green, when it is only a point, this point has gravitational potential. This point has potential, it can do work, but right now it is not doing work because there is nothing there, just a point. There are so many points. Work is free. I can do a lot of work if I put things over those points. But when there is nothing there, what will happen? Nothing will happen. So it has potential. It has potential. As soon as I put a block of mass m here, the black one, as soon as I put a block of mass m here, this block of mass m now has gravitational potential energy. So without the block, without the mass, it is only gravitational potential. With the mass, it is gravitational potential energy. Without the block, it is only gravitational field. With the block, that gravitational field creates a gravitational force. So these are the four terms that we must understand. Gravitational force, easier one, everyone sees it. Gravitational field, tough, we don't see it. We can only find out its presence when something experiences force, there is field. Third, gravitational potential, we don't see. Fourth, gravitational potential energy, we don't see, but we see the effect it has. You store water at dam at a height, it falls down, lots of energy, running a turbine, producing electricity, class 12, electromagnetic induction, we would be doing it. So if you don't see something, that does not mean that it is not there. It is there, it is all there. There are a lot of things that are there in this universe which we don't see. In fact, scientists believe that only 25 to 30% of the universe is what we see right now in front of us. It's 70% is hidden. Even that 30% is just too big to imagine. So, I mean, we are very small. We are very tiny in terms of the entire universe. Once you study physics, when you study astrophysics, you will understand that our lives hardly matter. The entire Earth hardly matters. There are billions and billions and billions and billions and billions and billions of galaxies, and there are billions and billions and billions and more billions of stars and more billions of planets. Don't know how many lives are there. They are so far advanced that we are just they're not concerned. That's why we don't see aliens and all those things happening, because we don't matter. We are just too young for understanding. So that is what we understand now, but we are developing, and one day we might be able to colonize Mars, and maybe your generation is going to stay there. They have started creating condoms of what do you call condonium there, where you are going to stay, and for first all these astronauts will stay there, and then they will create a colony for you. Maybe your generation and the next generation will be staying on Mars. Anyways, right now what we know is gravitational force, gravitational field, gravitational potential, and gravitational potential energy. All are similar terms. If you understand one, you should be able to understand all. Earth, big mass, creates gravitational field. You put another mass, it experiences force. Earth, a big mass, creates gravitational field. That gravitational field creates gravitational potential. It cannot do anything. But if I place a mass, that becomes gravitational potential energy. That is all for today's class. We'll wind up today's class here at this juncture. In the next class, we will be dealing with the definition and concept of gravitational potential energy. That would be in your next class. If you have any doubts, you can come up to me. If you understood this much, well, you have covered almost 1/3 of the portion of 12th standard as well. It's all about field and forces and potential energy. Electrostatics, more than half of electrostatics is this thing. So we have covered a half of electrostatics of class 12th as well. So I'll wind up your class here. If you have any doubts, you can come up, and don't worry about the mic. It will be okay in a day or two. If it doesn't work, right? Don't waste your time on tuck and puck. Throw it out. Okay? Chalo, we'll meet in the next class. Enjoy your day. If you have anything, I'm here. Ask. Take care.
Working now, sir.
Okay, see, things work. When you don't expect them to work, they work. When you expect them to work, they don't work. Anyways, doesn't matter. Mic works or not. My message should reach you. Your message should reach me. Mic is just a way of communication. We communicate in different ways. You can raise hand and communicate. Okay, don't worry. I'm still here. Anything? Ask. I'm here.